practicals, it is 50 marks. So practical is the passing cutoff is more than the theory exam. But individual cutoffs are not there. So student who scored less marks here can work hard and score good marks in the end semester exam. Then in the end semester exam, generally you have a 10 mark MCQ and 25 marks written test. So there are chances of getting a good score there also, and like completing your assignments and all in within time. Okay. So I'll give
Ma'am,
you
is there relative grading?
yes.
Relative grading is there or not?
No relative. It's all absolute. The cutoffs for first year, BTech first year, chemistry subject are never relative. They are absolute and they don't deviate, like we don't deviate. But the cutoffs are not exactly like some grades, because according to the absolute grading system, the lower cutoff is, I think, 50 marks. But the chemistry department maintains it at 40 marks. Okay. So every year it is 40. For all section, it will be common what all cutoffs are there. It's like you are WXYZ section now. In the next semester, RSDUL section will come for chemistry, and you will move to physics department, or physics subject will be there. So for both the semester, the chemistry of BTech first year is same, so cutoffs are same. Okay. So
Ma'am,
we can, yes.
handwriting is mandatory, ma'am. Good handwriting in examination.
गुड हैंडराइटिंग होना इसलिए अच्छा है कि बहुत खराब हैंडराइटिंग रहा तो इवैल्यूएटर और वन हु इज करेक्टिंग may find difficulty in reading. So it's better to write in legible handwriting, scan it properly and upload. अब अभी अगर आप यहाँ कोई स्टूडेंट है इंस्टीट्यूट में, तो लाइक वी शो द आंसर शीट्स. Okay, but now we are not showing answer sheet. If you are satisfied with your marks, we don't open the answer sheet. Otherwise, if you are here in the in the institute, then you have to go to every department, see your answer sheet, evaluate like all the answers are corrected or not, and then you have to put your signature on the answer sheet that you have seen this answer sheet, and the marks you got, you know. Okay, then then the marks are compiled and then they're entered. So every semester it will be like the end sem answer sheet you have to see, because after your end sem exam you are not allowed to go home immediately. At least for 5 days you have to stay here and check your answer sheet for all the subjects. And then if someone is having back or re, immediately in 15 days you have a re-examination also. Okay, so those who don't score 40 marks, they have to stay here and read for exam. This is the offline pattern I'm telling you. Now in online also you have a provision of re-examination just after 15 days. So those who can't score here should work hard for, like if they fail in one or two subjects, they should go for that. Is any other query? Yeah, it is good that you have such queries now. Anything else?
Ma'am, do we have to keep the original answer copies with us?
Your original. It is better to keep everything original. Like you wrote some experiments which you have uploaded, right? Four
Yes.
experiments, the answer sheet which you wrote. Because if it is opening, because 18th February only it is said. Now after 18th February we anticipate that MSc, MTech, MSc first year, second year, MTech first year, second year, and the third and the fourth year of BTech may come to the institute, because the number is declining. Nagpur is now not that like it's quite safer now. So the wave has subsided. So most probably by 20th of February, we will be having some clear picture. And when the first year are asked, I doubt first and second year BTech, because the number is more, 900 both the years. So 900 plus. So total becomes 2000 students overall for just first year and second year. And accommodating so many students in hostel, immediately तो शायद नहीं होगा, Lekin you can't say, means I can't say anything on this particular issue, that when you will be called to the college for offline classes. Okay, so we consider that we have to go with the online till you have your end semester exam in second week of March, right? Second week of March is 14th onwards. But your exam, I think, is starting from 12th only. 12th of March. 12th of March is. Have you seen your academic calendar? When is your exam starting? Ends and paper? Maths? 12th March is ends and paper. So if 12th March is ends and paper, I should finish your syllabus by 4th of March. 1 week I never drag the course till the last day. So at least because number of submission, assignment, ye reh gaya, wo reh gaya, will be there. Okay, so I have to finish your course. Today is 10th of February, and by 5th of March, Saturday, I should complete your portion. Anything else?
There was a
Ma'am,
quiz
excuse
which
me,
was
ma'am.
postponed.
Okay, Atharva, you ask first, then she will ask. Okay, what is your
Ma'am,
question?
there was a quiz before our midsem which was postponed.
Quiz, theory quiz.
Yeah, yeah.
Okay, I'll work out again because you see, I have two courses simultaneously going on. One is your BTech first year, and I have MSc second semester, and they have their practical also. So I'll just work out again and see that how I can take it. And it is always better that I put a quiz on the entire syllabus. So just before your end semester exam, everyone will be put to forcefully read the syllabus, read the contents, at least know what topics are present in which lectures. You will be knowing, right?
Yes, ma'am.
Anything else? Someone was asking some more thing was there.
Ma'am, these midsem marks will be added in the end semester, ma'am, like for the points that we
Yeah,
get in.
yeah. This is 25 marks. So whatever you scored out of 25 plus the end semester out of 35 plus uh, what I told you, I'll give you an assignment for 10 marks. I'll take a viva for 20 marks and or viva will be for 10 marks and I'll give you a quiz of 20 marks. So that will become an internal 40. So that 40 plus this is how much? 60.
Ma'am.
25 plus 35 is 60 and
60.
internal will be 40. Yeah. So overall it will be summed up and the total. So you should note down in your diary every test or quiz or assignment what you are submitting. That did you submit in right in time? How many marks you got for this quiz? Subject wise, practical and theory. So that when I will say that you check your marks, are they added and the summation is correct or not? That time you should be knowing all your marks properly. Out of 25, out of 10, out of 20, because out of 20 quiz will immediately will be generated. Na? The moment the last student submits, I release the score. Okay, so should we start with the portion now?
Yes, ma'am.
Yeah, Viva of X2 students, some of you are remaining. I think I'll take it together at the NSEM part. And your NSEM practical exam will be during 21st to 25th. I think I should take your practical exam so that this Saturday I'll take two experiments and I'll identify some common time for all the four batches and the remaining two will be taken up. What is their ion exchange capacity of a cation exchanger resin is remaining. Then adsorption, verify the Freundlich adsorption isotherm is there. Then you have an experiment on determination of cobalt colorimetrically. And fourth experiment that I will take is determination of gross calorific value of coal sample using a bomb calorimeter. Okay, so that is something regarding fuels, but that is a very good experiment. So these. Now the experiment on kinetics, I am not taking, considering that you have already studied kinetics, and just orally saying that this is the procedure and these are the readings is of no use unless you perform it in the lab. So that experiment I will not give you. So you will have only 8 experiments to read and 8 experiments to write and submit. Things are clear? 8 or 9. Your DO free chlorine, alkalinity hardness that you have already submitted, then ion exchange capacity, absorption, cobalt colorimetrically, and bomb colorimeter. Yeah. So 2 on this Saturday and 2 one more day, so that we can have the exams completed for that. Like the whole evaluation should get over by 25th or 26th of February. Clear?
Yes.
I took 15 marks MCQ test, 15 marks Viva for most of the students is over. So only few students are remaining. So I'll take it all together. The remaining 70 marks, again 10 marks will be on your submission of your file and all. You get 20 minutes are as such over. Okay, so should we start the next topic? Now the topics that are remaining is corrosion. Then after corrosion, you have polymers. Then you have some name reactions, three or four name reactions, crop synthesis, um, Riemann reaction, Beckmann-Hoffmann reaction, and one more, I think. So only three or four name reactions are there. Then organic, then coordination. What are coordinated complexes and what is coordination number? What is coordination sphere? What is secondary primary valencies? Nomenclature of coordinated complexes. I think that's it. And the chelate effect, stability of a chelated complex. So that part is there, and then you have a small portion on interaction of radiation with matter, how light interacts with matter, and number of things right from like how the light is used for chemical analysis. Okay, to identify the molecular structure, the compound, and all those things. Anything else? So should we start with corrosion? Should we start with corrosion?
Yes, ma'am.
Yes, ma'am.
Okay, so that is good. So initially, we see that some part of electrochemistry, which is necessary for corrosion studies, is incorporated into your syllabus, and that is what we are going to study today. Now, corrosion. Um, First of all, we see how you get metals. Now, metals are present in nature in form of ores and minerals that you can see here. So these are like you have hematite, magnetite, limonite. These are iron ores. Then you have corundum, that is Al2O3. Then you have bauxite. This is a bauxite, Al2O3 twice H2O, and and many more ores for different metals. Different type of ore material is there. So these ores are excavated from the earth crust, and they are put for ore concentration by either magnetic separation or froth flotation process, and then you are getting some concentrated ore. This concentrated ore is put as charge along with some fluxes. So this charge and fluxes, this is almost 50 meters high or 5-story building or more than that, such height of blast furnace. Now in this blast furnace, this know how much energy and treatment. Now, which can actually identity and state. Okay, so and as we use and application. Maybe Indo application of now we have get identity um form so because in what is form after extracting metals they are presented then practically stable form and why each over a period of time they undergo corrosion. Is very answer to that is after spending a lot of started presently on of mental to corrosion changing the way of talking of interaction environment and substituting atmosphere social will have its resistant and now I have to outside which is not moisture and oxygen sound as and need a basic knowledge of chemistry. series, galvanic and electrochemical cell or electrolytic cell, then concentration cells, decomposition potential, polarization and overvoltage. This is the part which is there in your syllabus. Okay. So first of all, tell me what is oxidation?
Previous
Yes.
slide, please, ma'am.
What is oxidation?
Ma'am, previous slide, please, ma'am. Okay, ma'am.
Okay. So what is oxidation? Loss of electron. Okay. And what is reduction? Gain of electron. So you can talk in terms of electron or proton. So loss of electron or gain of proton is oxidation, and gain of electron or loss of proton is reduction. Now the surface of metal where oxidation takes place is termed as anode, and the surface of metal where reduction takes place is termed as cathode. It is not necessary that the two should be dissimilar metals kept in an electrolyte solution. In corrosion, you will see that a single metal plate, on the surface of the metal plate, some area become anodic and some area become cathodic. And it is possible that a single plate of metal, the area which undergoes oxidation is termed as anode. Okay. Then indicator electrode. Now for measurements of number of things you need certain electrodes. Generally you can't measure the potential of half cell. So you need two electrodes. So two electrodes are mostly an indicator electrode and a reference electrode. So you couple them and find out the E cell value. So an indicator electrode is one whose potential varies in a known way with variation in the concentration of analyte. And reference electrode is the one whose potential does not change at all, and it is for example, standard hydrogen electrode SHE. Then you have calomel electrode. Another type is silver chloride electrode. So they are the reference electrode. Then liquid junction potential. Now when two electrolyte solution of different composition are in contact, there is potential difference across the interface due to unequal distribution of cations and anions as a result of difference in diffusion rate. And this leads to formation of a development of a liquid junction potential represented by EJ. Okay, EJ is the sign for this, and the complete cell potential is termed as E cell. This is E half, and this is E half for your reference electrode. Okay, so this is generally like depending on what reaction is going on here, you can write this as your reference electrode, so it can be written on right hand side. Then the salt bridge. Salt bridge maintains electrical contact between the two half cell of the cell. It reduces liquid junction potential. Now, salt bridge is generally like you must have seen an inverted U tube containing agar-agar and KCl. Now, it is meant for electrical connectivity between the two half cells, and we use KCl so that KCl, K plus and Cl minus, they have equal ionic mobilities, and that is why they migrate with equal speed. So they do not produce much of liquid junction potential. So using KCl will reduce the liquid junction potential. Okay. Coming to electrode potential, what do you understand by electrode potential? So when you place a metal strip in a solution, electrolytic solution or water, we find that there is accumulation of charge on the surface of metal and around the surface of metal in the electrolytic solution. Now this double layer is termed as Helmholtz layer, and this charge separation is termed as potential difference or the electrode potential. So the tendency of metal to go into the solution as ions when dipped in water is termed as electrode potential. So Is it only that the electrode which will go into ions has electrode potential? Like you have platinum, gold, silver, they will not go into the solution. Okay, but they will be having a like they are more noble, so they will be having negative charge so that the positive charge remains over here. No, they will be having positive charge so that the ions start accumulating here for deposition. So you will find that like the deposition or reduction takes place at the noble metals. Then the potential uh, existing between the metal electrode and the surrounding ionic solution arising out of an electrical double layer Helmholtz layer due to spontaneous redox reaction is called electrode potential. So this is more proper definition for electrode potential. Okay, so writing this will not fetch you marks because this is half the way. The rest of the things are not explained by this particular definition. So this the potential difference between the anode and the cathode in a cell is called the electromotive force, also called the cell potential and designated as E cell. So two half cell are coupled together and the E cell of uh, the EMF of the complete cell is measured after coupling the two half cell and connecting the electrolyte solution with a salt bridge. And then what you measure with a voltmeter is termed as electromotive force or the E cell value. So E cell value will be always E half right minus E half left. We generally say your right is the cathode because reduction is taking place here, and this is the anode where oxidation is taking place. This is just a sign convention or just for convenience. This thing has been said that E right is always the cathode and E left is the anode. Okay, this is just generally what is said, and you must have solved or could perform number of calculation in electrochemistry in your 12th standard considering this. But if you connect such two cells, suppose that this zinc is here and copper is written here. So will it not form an electrochemical cell? Whether you write it here or write it here, it will form a electrochemical cell. तो जिंक को आप यहाँ लिख रहे हैं और कॉपर को यहाँ लिख रहे हैं, इसका मतलब कॉपर पे रिडक्शन नहीं होगा, ऐसा नहीं है. So you have to forget this basic concept of 12th standard कि the right is always the cathode or the place where reduction is taking place. When you start reading the corrosion chapter, you should think that madam is sitting on the other side. There is a table on which the two cells are kept, and you are sitting in the student's chair. Okay. So if I keep it on my right hand side, what you will look from the other side is you will say that zinc electrode is on your right hand side. But when I connect it with a wire and a salt bridge and a single electrolyte solution, if it is there, so if a single electrolyte is there, there is no need of a salt bridge. So if you have a single electrolyte, will the cell not work? Yes, the cell will work this way. Like this is the zinc and this is the copper electrode. So if you connect them together with a wire, whether you write on right hand side or you write on left hand side the copper electrode, the reaction is going to take place. And what reaction is going to take place? Reduction at copper and oxidation of zinc. Zinc will undergo oxidation forming Zn2 plus ion, and two electrons will be running in through this wire in this direction. And when the electrons move in this direction, we say that the current is flowing in the opposite direction. This is what is tau. So the relation between electrode potential and the concentration of the metal ions is given by Nernst equation. So it is physically impossible to measure the potential of a single electrode. Only the difference between the potentials of two electrodes that completes a circuit can be measured. So what you can measure is this part. You can't measure E half or you can't measure this E half alone using this voltmeter. You have to couple two half cell, then only you can measure the E cell, that is the EMF of the complete cell. And what is this EMF of the complete cell? So this EMF of complete cell is equal to E cathode minus E anode. Now you write anywhere your cathode anode, doesn't matter. Wherever reduction is taking place, that becomes your E cathode minus the E anode. Okay, so you try to forget your concept of E right minus E left. You start remembering that E cell is always equal to E cathode minus E anode. Okay. Now coming to like to measure the potential of any such electrode, what is required is the standard hydrogen electrode, which is a completely reversible electrode. And because it is completely reversible, it is used as the standard or the reference electrode. Now the reaction that takes place is twice H plus aqueous, 1 molar acid solution plus 2 electrons. It gives H2 gas, and a reverse reaction may also take place. So in this particular cell, you will find there is a platinum foil. On the platinum foil, hydrogen gas is uh, continuously passed at a pressure of 1 atmosphere, and that is being bubbled over here, and the HCl concentration is 1 molar. Then the reduction reaction is this, and the oxidation reaction is maybe this. So the potential of, because it is a completely reversible electrode, its E naught or E half value is considered to be 0.000 volt. If you connect two half cell in which either hydrogen pressure is differing, then there will be setting up of a galvanic cell, or if the acid concentration is different, still there will be setting up of a galvanic cell, right? Or an electrochemical cell. And just a minute. Okay, so this is taken as 0.00, and this is definitely or necessary that the hydrogen gas pressure should be 1 atmosphere and the acid concentration should be 1 molar. So this is used to determine the half cell potential of other electrodes, and the standard electrode potential for number of metals is determined by putting the electrodes or the metals into their own salt solution of 1 molar concentration, right? So what is standard electrode potential? Standard electrode potential for a half reaction, that is E naught, is defined as the electrode potential when all reactants and products of a half reaction are at unit activity. Activity for dilute solution can be replaced by the terms concentration. Okay, for at unit concentration, you can say for dilute solution. So, an important physical constant that provides quantitative information regarding the driving force for a half cell reaction is this particular E half. So, if you are having one cell which has an E half of 0.5 and other cell having an E half of say 1 volt, then definitely there is the difference in the E half values or E naught values, and due to difference in the E naught values, a electrochemical cell will be set up and it will start working, right? So it is a relative quantity, as reference electrode is SHE of uh, potential 0.00. So all the half cells are coupled with standard hydrogen electrode, and their tendency, whether it is undergoing oxidation, if it undergoes oxidation, because the standard potential is always written as relative reduction potential, it will be having a negative sign, or if it undergoes reduction at the that particular half cell, then that will have a positive sign. So it refers exclusively to the reduction reaction, that is relative reduction potential only. Then E naught is independent of number of moles of reactant and product shown in the balanced half reaction. A positive E naught indicates a spontaneous half reaction with respect to SHE. So E naught for a half reaction is temperature dependent. So that is how you measure the E naught values. And when you measure the E naught values, how do you measure the E naught value? You have, say, considered that you have a standard hydrogen electrode having 1 molar hydrogen ion concentration and 1 atmosphere hydrogen gas is put into this. Okay, now this half cell is connected to one of the terminal of your voltmeter and the other your indicator electrode or one whose potential you want to measure, E naught value you want to measure. Suppose if it is zinc, put into zinc nitrate solution of 1 molar concentration. Now this is connected to other terminal and you measure the voltmeter reading. Now the voltmeter will show 0.76 volts. Now what does this mean? This means that when you are having this particular thing, if you write this as your right and this as your left, your this reaction has to be always written as reduction reaction. So twice H plus 2 electrons giving you H2 gas is having 0.00 volt potential. E naught cathode. So this is, since it is a reference electrode, its potential will not change. Then you are coupling it with zinc. So zinc is undergoing oxidation. So if it is undergoing oxidation, you write it as E anode. Okay. So the E anode we are not knowing. We want to measure. Now when you couple these two and you try to find out what is this value 0.76. So when you put your E cell value as 0.76, which is equal to 0.0 minus something x comes out to be minus 0.76. So although E cell is positive, the zinc undergoes oxidation and hence assigned a negative value. It is having a negative value. So the negative E half means electrode acts as anode and oxidation half cell. Okay, so this is very well known to us. Then if you connect it to copper, then copper will undergo reduction and at the standard hydrogen electrode, it will undergo oxidation. So when it undergoes oxidation, this is 0 and the overall reaction is this. The cell potential that reads is 0.34. So your value of E naught cathode comes out to be 0.34. Okay. So similarly, you can use number of other metals and place them into their own salt solution of 1 molar concentration and get the value of E naught. And once you get the value of E naught, or the scientist got the value of E naught for every metal, they arrange the metals in such a way that there is increasing order or the metals are arranged in the increasing order of their reduction potentials. And then they call this series or this table as electrochemical series. So what is electrochemical series? When metals are arranged in the increasing order of their standard reduction potentials from top to bottom, it is known as electrochemical series. Half cell potential for common electrode materials at 35 degrees centigrade measured with respect to standard hydrogen electrode. Okay, so these values are measured with respect to standard hydrogen electrode. This is the standard hydrogen electrode value here, and the standard electrode potential is a quantitative measure of the readiness of the element to act as a reducing agent in aqueous solution. So these metals which undergo oxidation, they themselves are undergoing oxidation, means they are reducing others. So that is the measuring curve that is measured here. So the more negative the potential, the more powerful is its action as a reducing agent. So these are the reducing agents, and the difference between the two metal, if it is more, then the reaction will be more. If the difference between the two metal is less, the electrochemical reaction occurring will be less. So this is an complete table for number of reactions, number of half reactions occurring. Okay. Then coming to E cell equal to E cathode minus E anode, both expressed as reduction potential. This is very important part. Both expressed as reduction potential. Positive E cell value, spontaneous cell reaction. Negative E cell value, non-spontaneous reaction. Now negative E cell value का मतलब है कि अगर आपने connect कर दिया तो is it that it will be non-spontaneous? You have to bring about electrolysis. No, if there is difference in the potentials of the two half cell, you will find that it will start working. Okay, and although it is negative part, so the other electrode starts working as the oxidation takes place, and the other electrode reduction will be taking place. So that is the thing that although you say that there is a negative electrode potential, then you have to assume that the sign convention given to those two electrodes which you are considering is the reverse of what actually is. Okay, if you understand this concept, then the understanding corrosion is very easy. Various types of corrosion and all. Okay, and I consider that you understand this part. How many of you think that you understand what is written here?
On the top, ma'am.
The third line, negative E cell value is equal to non-spontaneous cell reaction. I say that in a galvanic cell, there is never, or electrochemical cell, if you get a negative cell value, does not mean that the cell will not operate. Only thing is when you are considering it, it is the reverse, the anode and the cathode are reverse. Do you understand this particular thing?
Yes, ma'am.
Okay, then we can go ahead because that is the thing which is helping you to understand corrosion. Now this you can say that in an electrolytic cell कोई electrolyte है उसको fuse किया आपने और fuse करने के बाद you want to deposit them at the two electrodes, then it is fine saying that it is a non-spontaneous and you want to bring about electrolysis like separation of Na plus and Cl minus or K plus and Cl minus, anything of that sort. But here in corrosion chapter, when we are talking about the metal and especially iron, then having showing that the negative E cell value, will the corrosion not take place? Just now I have told you an example. If I am standing on this side, the beakers are kept on the table and you are standing on the other side, the cell will start working whether it is kept on right hand side or left hand side, immaterial of that, and it will start working. The place where you have a positive potential, reduction will take place. The place where you have a negative potential, oxidation will take place. Things are clear? You understand this basic part? Okay, then we go ahead. Application of ECE series. To predict, now the electrochemical series predicts the relative oxidizing and reducing powers. It predicts whether a metal will react with acid to give H2 gas. Now the example to cite this, like if there is a metal like mercury, mercury offers a very high over voltage for hydrogen gas. So before H plus in acid, because this is acidic medium, right? So H plus will be there. So before H plus can get reduced to H2 gas, the metal undergoes reduction and H2 gas is not formed. And this happens on the surface of mercury, Hg. Okay, and mercury is a liquid metal, so immediately if from solution, if zinc or copper is depositing on mercury, it leads to formation of an amalgam, zinc mercury amalgam or copper mercury amalgams are formed. So that is a very good thing to find out what is the potential up to which you can use the metal without liberation of hydrogen gas. Okay, then predict spontaneity of any redox reaction, predict replacement tendency, to predict the current metallurgical methods, different type of metallurgical methods that you are having that you can study. So the electrochemical series gives information regarding chemical reactivity of metal but is unable to provide information in predicting the corrosion behavior in a particular set of environmental conditions. And therefore, after the electrochemical series was formulated or tabulated, after tabulation of electrochemical series, then another series was tabulated and it was termed as galvanic series. Now, in galvanic series, it was the oxidation potential that was measured. The oxidation potential measured for different metals and their alloys with respect to a saturated calomel electrode as reference electrode. And the assembly was immersed in seawater and arranging them in the decreasing order of activity is known as a galvanic series. So most active ones are kept at the top and the most passive ones are kept at the bottom. So this is when you arrange the metals according to the oxidation potential of metals and alloys, and these oxidation potentials are measured with respect to saturated calomel electrode and not the SHE or standard hydrogen electrode. And that is how, and it is not immersed in 1 molar concentration, but it is immersed in seawater. So when you place it in a 4% salt solution, different type of salts are there in the seawater. So such kind of determinations were there, and then the metals were arranged from active to passive, and this series or this table was then is termed as galvanic series. So it gives a more practical information on the relative corrosion tendencies of the metals and alloys. The speed and severity of corrosion depends upon difference in position of metals in the series. That is, if you are having, for example, copper and bronze are connected together, the rate of corrosion will be very less. But if you are having zinc and gold, if you connect zinc and gold, you will find that zinc undergoes very fast uh, rate of reaction, or the rate at which corrosion takes place is very high because there is difference in the electrode potentials of these two, whereas you will find that the rate of corrosion is less in where you have smaller gap. So for today we will stop here, and the next part we will see later. Okay. So tomorrow morning 10 a.m. we have a class. So we will see the next part tomorrow. Things are clear?
Yes, ma'am.
Yes, ma'am.
Any doubt
Yes,
till now?
ma'am.
No, ma'am.
No. Okay, good. So
Excuse me, madam. I have one doubt, ma'am.
yes, yes.
Ma'am, when will be the college reopening, ma'am?
I don't know. Nor there is any circular till now.
Okay, thank you, ma'am.
Ma'am,
Yes,
ma'am, in NSEM, midsem syllabus is included.
yes. Included, but I think little lesser weightage.
Okay, okay.
There's more weightage on the new part will be there, and that will be there. You आपका लाइन सोडा कैलकुलेशन तो शायद होता है. It is there. But it is a 25 marks theory paper, so I doubt corrosion से numerical डालेंगे या time soda से. I can't say. Okay. Okay. So for today we'll disperse here, close here.
Thank you, ma'am.